So government expenditure on education at lag 1, government expenditure on education at lag 6, government expenditure at lag 1, government expenditure on education at lag 2, government expenditure at lag 3. So what the forward does for us is that the forward presents us with the list of acceptable variables to add. So it is not expected that while conducting our regression analysis that we can now use these variables. These variables can be used for the purpose of regression, given that their p-value, you can see the p-value here, are very, very significant. The p-value is very, very significant, given that the p-value like for gx, the gx at lag 10, you can see at lag 10, which is 0.0000 is far less than 0.05. So you can see, and when we check also GED at lag 1, that is at lag 1, this variable now, you can see here the p-value is 0.0011, is also less than 0.05. So you can see that it is stable, and the forward method tells us that we can accept all this. And you can see here the selection summary. It says add this, add this, add this, add this, add this. So what the forward does is that it includes. The forward is to include the variables that are selected. That is what the forward stepwise regression does. It tells you add these variables. It is okay for you to use these variables for your model. That is what it does. But the backward tells you remove. And so we are going to see that in a little while. So let's work on the backward elimination process of stepwise regression. Now, we want to carry out the backward elimination. We just conducted the forward, so let's do the backward to see if it will remove the unwanted variables based on the lag system. So this is my data set. I'll go to quick, and this is quick. I'll go to estimate equation, and I'll go to method, and I'll locate stepwise least square, and I'll enter my dependent variable, which is GDP, space plus my constant, and I'll enter my list of regressors, and I have GEX, which is my government expenditure. Open my bracket, lag 1 space 2, let's say to lag 5. I'll close my bracket, space GED, open my bracket from lag 1 space to lag 5, and I'll close my bracket, and I'll go to option. This is option, and I'll go to backward. Now I want to check for backward. This is backward, and I'll go to p-value for backwards. I want to look at 5% level of significance, and so I will change this to 0, so it will give me 0.05, which will be my criteria of judgment. So the criteria of judgment, and so I will press OK, and OK. So this is my result, result for the backward stepwise regression. You can see here these variables here are the variables that are expected to be included in the variable. Yes, that government expenditure on education at lag 1, government just the same thing that the forward chose is virtually the same thing that this. Apart from this, you can see on government expenditure on education. You can see this variable is not significant. This is not significant at all, and so we expect to drop it. Given that, you can see this is 0.09, and 0.09 is greater than 0.05, so we have to drop it. Now, a government expenditure on education at lag 5 is 0.05, which is equal to 0.05. That simply means we can add it up. Now, when you go to the remember we're looking at lag 5, from lag 1 to lag 5. So this is the selection summary. The selection summary here, you can see the number, the ones is telling us add, remove, remove this, add this. So that is all about stepwise. Stepwise is just what gives you a logical and a mathematical expression of a variable to add. Most researchers use this, but it's not backed by theory, as I explained to you earlier on. It's not backed up by theory, but most of the times it could be backed up by theory, and most of the times it will work. It may work. So you may decide to use the stepwise elimination process to carry out your data to see which data to eliminate and which data not to eliminate. I may decide to keep it at lag 1:1. So let's try lag 1:1. So this is 1, lag 1:1, lag 1:1, and let's see the outcome. So you can see at lag 1:1 is telling me that no regressors were chosen by the stepwise routine. That simply means that these two variables are good for the test. Is a good model. That simply means when we use government expenditure at lag 1, government expenditure on education at lag 1 is a good association, and it has a good relevance with gross domestic product, that is at lag 1. But let's see, if we step up, I go to estimate, I say, okay, let me increase this to lag 2 and see if I will be if it will give us the same outcome. So at lag 2, you can see here that it's telling us remove government expenditure at lag 2, and let's see government expenditure at lag 2. That simply means government expenditure at lag 2 is not a good model. That simply means if you carry out a regression analysis with government expenditure at lag 2, it will not give you a good outcome, and it has chosen that we should include government expenditure at lag 1, government expenditure in education at lag 1, and government expenditure on education at lag 2 as a good variable. So these are the areas that you can do. Carry out stepwise and elimination procedure using the stepwise elimination means. So I made an interpretation note here. I say if the p-value is less than 0.05, then the variable has a significant association with the outcome variable. The outcome variable here, we're looking at GDP, and that simply means it can be added. If the p-value is more than 0.05, then that variable cannot have a significant association with the outcome variable, which is GDP, and then the variable can be dropped. As simple as that. Then the same applies to either forward selection or backward elimination. So anyone you can do. So I hope you were able to understand this, and you can be able to conduct this analysis, and yes, you're able to conduct this analysis, Of course, it's very easy to learn, and if you can practice over and over again, you'll be